I'm Christina Buffington, Science Education Specialist at International Arctic Research Center at University of Alaska Fairbanks. Thanks for joining this bundled workshop using phenomenon-based bundles through the GLOW program to facilitate student research projects. And thanks for checking this video out. You'll have some tools that you can use in citizen science. And this presentation is called A Sense of Loss, Then Just One Change, engaging citizen scientists to ask their own research questions. And that's exactly what the undergraduate students are doing in this picture on the left. They're floating the Chena River through downtown Fairbanks and using the GLOW water quality bundle to collect data about the Chena River. Some people have a sense of loss about the Chena because the populations of returning salmon are less and less every year. And the Chena River is a tributary to the Yukon River. And rather than just dwell on this loss, I made one change in my citizen science practice by engaging citizen scientists, including undergrads, to ask their own research questions. And that has led to some really awesome projects that they have done on their own. The Troth-Yetta campus is the University of Alaska Fairbanks main campus. It is a hill that is up above the Chena River, and it is a sacred site of the lower Tanana people. The whole Fairbanks area is in the traditional lands and waters of the lower Tanana people. And I honor and thank their stewardship, both past, present, and future, so that salmon can continue to return and that we all can continue to work on healing and restoring this land together. That's what my students are doing in this picture. They hiked down to the Happy Creek, which was cut off from the Chena River back 85 years ago from mining. It's important for my students to see firsthand some of the damage from colonialism, and then also to learn some of the practices to restore it. Flow got restored in 2020 to the original Happy Creek and Cripple Creek channels. And I'll give you a map of what this presentation is all about. First, I'll share the Arctic and Earth STEM Integrating Globe and NASA Citizen Science Framework, and hopefully that it will inspire you as much as it does me. Then I'll give an example of how undergraduates at UAF are taking a deep dive in the GLOW water quality bundle, which leads them to their own research questions and projects. And finally, just stay on to the end, I will share tools that you can use to help citizen scientists develop their own research questions. What's next? Local knowledge. I talked a little bit about the importance of the Chena River, and it's important to first learn from local people, especially long-term knowledge holders and indigenous people, and also scientists about what's going on in the land and the water in the place that you live. Then identify a key issue that will focus your citizen science investigation. And in this case, the key issue was juvenile salmon. You see a picture here of a juvenile Chinook salmon. And then my undergraduate students learned about the Chena River through culturally responsive activities. They spoke with a NASA scientist that Bonnie Murray with NASA had connected them to, and also local scientist Katie Spellman and Elena Sparrow. And my students each selected their own inquiry question using the question formulation technique to help that process out. Then they analyzed their data, presented it, and some of them went on to design and actually implement a project here in the Fairbanks area to address the issue. So let's learn next about the GLOW Water Quality Bundle. And the bundle is all of these different protocols, precipitation, and also the pH of precipitation, soil pH, pH of surface waters, the alkalinity of surface waters, the conductivity of surface waters and dissolved oxygen, the nutrients, especially we look at nitrates, water transparency. We use a transparency tube and a Secchi disc to do that. Water temperature and air temperature as well. The student here is taking air temperature. And then freshwater macroinvertebrates. So in this case, in this example on the right, you see a graph using a Vernier dissolved oxygen probe, and students, this student here with her arm down is collecting dissolved oxygen data all along the river, and you can see these peaks and valleys over time with the concentration in milligrams per liter on the left axis. To find more about the Globe Water Quality Bundle, I provide this link here. You saw that graph, a little bit about variability of dissolved oxygen. My students explored that further and asked some additional questions about what they found out on that float trip. So data leads to further questions. First of all, let's dive into this question formulation technique. I want to give credit due to Sarah Westbrick, who I got this slide from during a training by the Wright Question Institute. And what college presidents have said on what students should be learning in college are that they should really learn analytical skills of interpretation and inquiry. College presidents want students, after they graduate or while they're in school, to be able to frame a question. And this quote comes from Rothstein. The best we can do for students is to have them ask the right question. This is Nancy Cantor, Chancellor of the University of Illinois, saying this. And these were published in the New York Times in 2002. However, the Project Information Literacy University of Washington study found that only 27% of undergraduate students believe that college taught them to ask their own questions. So clearly undergrads need to learn these skills, but it starts much, much earlier than that. I used to be a middle and high school science teacher, and I knew that I was doing the asking and the students were doing the answering instead of the other way around. So that's why I find it important to make one change to teach students and also citizen scientists to ask their own research questions. Dan Rothstein says, you are ready to learn more when you've asked the questions yourself. So in this example, I had my students look at the data and ask questions of the data, and I kept my mouth shut I gave them a prompt, and I was quiet for 3 minutes while they generated their own questions and then later learned to improve those questions. I could have told students that on the left-hand side, the dissolved oxygen concentration axis ranged from only 10.415 to 10.445 milligrams per liter. But rather than telling them that and then giving them the conclusion that even though it looks like there's variability in the data, the scale isn't large enough to have much variability. Instead, they came up with their own questions, involving significance, involving whether it matters to salmon, and whether the amount of time was long enough to measure, whether they needed to average the data in order to compare the data to another location, and what kind of concentrations of dissolved oxygen do salmon need when they're spawning compared to when they're juveniles. And also they wanted to look locally at the dissolved oxygen concentrations in the Chena River. So these great questions came in only 3 minutes of time, and I could have just told them about this graph and been done, and they wouldn't have cared. So this is one change that matters. And it leads to people like William Samuel, who's a senior at UAF, graduating soon. He's got a undergraduate research project that's been funded that was an outgrowth of this class. And we can hear him explain how these experiences have helped him and what it could mean for undergrads to ask these questions.
One of the course goals is to contribute to watershed management and problem solving in the local community.
If I'm staying in academia in a research setting, what kind of questions are the most important? What do managers and need to continue to improve their restoration techniques and other watershed management activities like this? So I think that transfer of knowledge between the university, if an undergraduate can go to a site and take those questions with them for the next couple of years throughout the rest of their bachelor's degree or a higher level degree, they can continue to develop those questions and issues and hopefully come out with a solution later down the road.
And another student, Chelsea Huckbody, who has graduated from University of Wisconsin-Stevens Point, was an exchange student for only one semester at University of Alaska Fairbanks. And she looked at the frost tubes that we have to monitor soil frost and developed her own comparisons and own research questions as well, and submitted this project to the International Virtual Science Symposium last year in 2020. So how did we get students to actually develop their own projects in just one semester, given Alaska's very short weather period of getting out and collecting data? Well, we got it going with the question formulation technique, and that's why I want to give you some tools. So the question formulation technique, summarized as QFT, on one slide, which was provided by the Right Question Institute, is this. First, there's a question focus or prompt to get students thinking of questions, and that prompt is never a question. Next, citizen scientists can produce their questions. There are some rules. There's a reason to have rules to make a simple technique to get people to ask questions. These rules are: number one, ask as many questions as you can. Number two, do not stop and judge or discuss or answer those questions. Number three, write it down on a piece of paper exactly as it's stated. And number four, change statements or phrases into questions. It's also important to number those questions so you can refer to them in groups later or even as an individual. The next step of the QFT is to improve your questions. First, you go through that numbered list of questions and categorize them as either O for open or C for closed. Now, a closed-ended question is answered with a yes or a no, or it could be a number such as data, a certain value. An open-ended question will require longer explanation, and we need both in citizen science. The next step is for participants to pick one question that's open and change it to the closed, and vice versa. Pick an open question and change it to a closed question. I said that. Pick a closed question and change it to an open-ended question. And that helps people improve and reframe their questions. The next is to strategize. Step 4 is to strategize by prioritizing the questions, which ones are most important and relate to the Q focus, and then create an action plan or discuss the next steps and share out those questions. And lastly, reflect on this process and what people learned. So I asked students to compare different soil samples that they had taken using some GLOBE soil moisture protocols. And you can see there were two groups of students, thus the writing on the left and the writing on the right. This was the board in my classroom on campus. And students asked mostly close-ended questions, such as what's the temperature, when did it rain last? But they also asked open-ended questions like, how much do we know about these samples? They then picked close-ended questions that they starred, and they changed them into open-end questions, such as what kind of effects do the pore spaces have on soil infiltration? So you can see that by improving their questions, they're coming up with even better ones that they can use for research. So the question focus is a prompt that stimulates questions. There's a lot of potential prompts. I use equations, graphs, data sets, or pictures the most, such as you saw one. You saw the variability in dissolved oxygen concentration graph. Then we can also use images over time, and you'll see, or images at one place, and you'll see that in the water quality bundle Google form that I share with you next. You can have a concept map, and that is the example with the weather bundle Google form that you can play with. And the experience of sampling soils that led to student questions on soil infiltration. So here's some examples that are tools for this workshop. The one on the left is the weather bundle, and it is simply a Google form, and you just go through it step by step, and the form asks you to reflect on the 4 rules of the question formulation technique, and then you're going to need a piece of paper and actually write your questions down, and then at the end of the Google form you'll put in your prioritized questions. And we also on the right have the water quality bundle Google form, and that one we will do together in a breakout room during the session, the live synchronous session. Check out the Dirty Snow poster, and we explain how we use the question formulation technique. So mark your calendars for Wednesday, May 19th. Now, if you're interested in this, I really suggest that you learn directly from the source. The question formulation technique is developed by the Right Question Institute, and if you go to their website and click on News and Events, you can see all the different online courses. Many are offered through Harvard University, and there's also webinars that are happening. That's where I learned the Google form process, is through a webinar last summer when I was wondering, how am I going to do this during the pandemic? The resources page has so many hundreds of free resources that you can download once you become a member of writequestion.org, and that is free. So thank you for listening to my story and being open to having citizen scientists ask their own research questions. If you have any questions yourself for me, you can contact me at my email here. You can also check out the Arctic and Earth Science website, the International Arctic Research Center website, the Right Question Institute, Globe, and my own personal page on Globe. I definitely want to give a shout out to the University of Alaska Fairbanks students in my class, including Chelsea Huckbody and William Samuel, and the Arctic and Earth Science team, Dr. Elena Sparrow and Katie Spellman, who have graciously brought me in on their citizen science projects to help coordinate them. And I am super excited to co-present this workshop with my co-presenters. I look forward to engaging with you in the synchronous session. Thank you so much.